Hello all, my name is Prachi Gohel and I'm a student of Bharati Vidyapit's College of Engineering for Women. Here is my project. My project name is Heart Disease Detection using ML classifier. So problem statement is we have a data which is classified if patient have a heart disease or not according to features in it. And objective of my project is to make a web application that will detect that whether a person has heart disease or not. So there are seven steps in ML. First step is load dataset. Second step is feature engineering, feature selection, and feature scaling, model selection, save model, and last step is deploy machine learning model. We'll start with the project. So importing libraries. So pandas is used for data analyzation. Matplotlib in Seaborn is used for data visualization, and NumPy is basically used for mathematical calculation. So first we'll load our data set. The data set here I am using is which I have taken from Kaggle. So this is my data set which I am using for this project. And first we'll load the dataset. Df.head is basically it shows the upper first rows of our dataset, which is suppose df.head shows. If I run this, it shows first five rows of the dataset. If we give, suppose here we give 8, so it will show first 8 rows of our dataset. So whenever we are performing any medical related project, first we need to learn our we need to study our data set. So age is in years, sex is one or female, uh, one one is male and zero is female, CP is chest pain, cholesterol, and everything is mentioned over here. So our main target is target one means that person is having an heart disease, and in target if zero is there, then it says that person is not having an heart disease. So now df.shape, it shows number of rows and columns present in the data set. So your 303 rows are there and 14 columns are there in our data set. Now to perform feature engineering. Basically, feature engineering is performed to check whether the null values are present or not in our data set. So to check null values, if uh, null values are present or not, df dot is null dot sum is used. So we here we can see that there is no null value present in our data set. So we are ready to go for next step. So using box plot, we have plotted a graph, and here we can see that these black dots are present in our graph, which are known as outliers. So these outliers should be removed from our data set. So using uh, from SciPy import stats and using Z score, we are removing our outliers. So there are two types of outliers to read and remove outliers. First is Z score and second is interquartile range. So here using Z score, we are trying to remove our outliers, and here threshold is equal to 3. We are just setting an value, so less than greater than 3 values will get printed in next step. And here q1 is equal to df dot quantile is 0.25, and q3 is equal to df dot quantile 0.75. So 0.25 and 0.75 is nothing but 25% and 75%. So this is an interquartile range. So after printing interquartile range, we can see that output is here. So now all values greater than 3 will get stored in a df.shape, and We can see that whichever values which were less than 3 are getting removed, and our data set shape has been reduced to 287 comma 14, which is 287 rows and 14 columns. Now we'll reduce it more by setting lower bound and upper bound. Again, we can see that our data set is getting smaller, which is 228 and 228 rows and 14 columns. Now, using the box plot, we are checking if outliers are removed or not. So here we can see the outliers are removed. Like in first figure, we can see first graph, we can see there were more outliers present here. So now in this graph we can see that only this and this outliers are present, which is negligible. Like we can neglect these outliers. So in feature selection. So using heat map, we are performing feature selection. So these red ones are positive correlation, these blue ones are negative correlation, and these sky blue ones are zero correlation. That means there exists no correlation. So this blue one we can drop, like I have not dropped over here, but you can drop this columns with zero correlation. That means there exists no correlation between them. So df dot describe. df dot describes gives us the count, mean, standard deviation, mean, max, everything using df dot describe. We can get count, mean, standard deviation, everything. So features scaling. First of all, we import standard scaler, and we'll using standard scaler we'll create standard scaler, and here we are creating dummy, that means dummy variables. So dummy variables are like for creating uh, accuracy will be more if you create dummy variables, and columns to scale, like we are scaling down the dummy variables, so values get scaled down, like uh, values get scaled down. So data set dot head, which will show first five rows of our data set. So here we can see that our values are scaled down, and dataset.tail will show us the uh, from lower five columns are shown using dataset.tail. Now dataset.describe, here we can see like count, mean, standard deviation, mean, max. The values are scaled down. And for data visualization, so here we can see that data is visualized, and this one KNN, which the points red, orange and blue points are like we cannot differentiate points. So this KNN will give us the more accuracy of our project. So let's see in model selection. In model selection, y is equal to dataset dot target. Target is like a person. One is for person having a heart disease or not, and 0 is for a person is not having a heart disease. So axis is we'll set axis is equal to 1. So from sklearn model dash selection, import train test split data. Basically train test split is used to test and train our data set, and this will show train and test our data set to for better accuracy of our project. So now using KNN, K nearest neighbor classifier will test our accuracy. So n neighbors will show that neighboring 5 points it will get to train our like to test our data set. So x train and y train is used, and score is equal to cross dash value dash like uh, KNN classifier, and we'll test the accuracy score like y test y predict KNN. So your accuracy is 91.03 per like and so on. So using score mean the accuracy will get accuracy of 0.80. Now here we are performing hyperparameter tuning. So hyperparameter tuning shows the more accuracy of our project. So using hyperparameter tuning, our accuracy of our project gets increased from 0.91. Here we can see 0.91. So here it is 0.97. And now using score mean, we can see that our project accuracy is 0.82. Now using confusion matrix, we'll plot heat map. So your blue box set should be minimum for better accuracy of our project. So we'll print the final accuracy of our project. So here we can see 0, that it is showing 100%, 1.00, which is 100% accuracy. That person is not having an heart disease, and person having heart disease, which is accuracy of 0.97%. So K nearest neighbor algorithm gives us the accuracy of 0.97%. So similarly, using random forest classifier, here I have test and trained the data, and it gives me the accuracy of 0.86%, and score mean gives the accuracy of 0.79. Using XGBoost classifier also I have tested the data, and it gives the accuracy of 0.89%, and score mean gives the accuracy of 0.82. Add boost with random forest algorithm is also trained and tested here, and it gives the accuracy of 0.86, and score mean gives the accuracy of 0.77. Gradient boost algorithm also I have tested and trained the data, which gives the accuracy of 0.89% and 0.77%, which is score mean. And finally, like we can see the more accuracy we got was in k nearest neighbor algorithm. So using K, we'll save the model, and using K nearest algorithm. So pickle will import pickle, and like this code is for save model, load model, predict the output, and confusion matrix, and show the accuracy. So accuracy of K nearest model is 0.79%. So using K nearest neighbor will deploy our project. So deploy in our project. So in deployment, here I have created a folder. So yes, here I have created one folder. In that folder, I have a static folder, which is the which contains the image which I have used for background in my web development. Templates contains the file, a .html file, which is nothing but our basic HTML code for designing our website. app.py is our important file, uh, which file runs our program. Model.pkl file is nothing but our model selection file. A proc file is nothing but the using Heroku. I am deploying this project. So Heroku is nothing but platform as a service, and Heroku tells us we need to tell Heroku that app file we are using for deployment our project. So your app is like I have mentioned app, so that Heroku is get that our file name is app.py. Requirement.txt txt is nothing but the libraries and files, which version of files and folders I have used in this program, in this project. And will uh, like I'll explain app.py. App.py is nothing but here we have mentioned flask. In that flask we mentioned model.pkl file, and this is the basic Python code for for giving the message that a person is having heart disease or no heart disease. And we have here imported the files which we have created for model, like model file and index.html file. So I'll run this code. So here we can see that our project website is created, like we have deployed our project. So here we need to give age, like age, cholesterol, the old peak is rest RG is 0, 0, 0, exchange is 0, 0, slope is 0, 0, 0, CA is will give 0, 0, 0, thigh will give 1, 1, 1. So now we'll predict. So here we can see that patient has no heart disease. So it will predict that whichever we give out input, the output will show that if patient is having a heart disease or not heart disease. So this shows the person is having no heart disease. So thank you so much for watching this. Here I end my project.